Hi Sam, how are you today? That's great. The learning target for today is to identify transformation by creating parts of the transformation using perpendicular bisectors. Now, what do I mean by creating parts? The two parts we're really going to focus on are the line of reflection and the center of rotation, and then we'll talk about a couple other things. But mostly, when I say creating parts, I'm talking about the line of reflection and the center of rotation. So we're going to go back into a bit of constructions again, taking out the compass and the straight edge, and using constructions to help us with transformations. For 3, you can identify the transformation and construct the correct part. 2, you can identify the transformation, but you can't construct the line of reflection or the center of rotation. 1, you can construct a perpendicular bisector, but that doesn't necessarily mean you have any idea about transformations. And 0, you can identify transformations or construct perpendicular bisectors. You can't do either of those things. Alright, let's get started. Alright, so before we jump into any of the constructions and stuff like that, I want to start off with just a little bit of vocab. So first, rigid motion. So a rigid motion is any transformation that preserves congruence. So, any transformation that preserves congruence is a rigid motion. So, any transformation that does not change the shape or size of the object is a rigid motion. As you'll notice, that's all the ones that we've done so far. Translations, reflections, and rotations are all rigid motions. Next, the line of reflection, which is the line an object is reflected across. So whenever it says reflection over this line, that's line of reflection. And in a second, we'll be constructing that line of reflection. And lastly, center of rotation. So that's the point an object is rotated around. Most of the ones we did were around the origin, but in some cases we changed it to a different point. So again, we're going to be constructing the center of rotation in just a moment as well. Alright, so see this picture here? We have two triangles and some transformation has been done to it, and you need to figure out which transformation. So if you're looking here, let's look and try to go through them. So first we've got translation. Well, the orientation's been changed. That's an easy one. You can say, okay, it's not a translation. All right. Then let's look at a reflection. Well, if it was a reflection, you have to look at where the line of reflection would be. So each point would have to be the same distance away from the line of reflection. So in order to show that it would be a reflection, we would have to create the line of reflection. But before we go into that, let's look at rotation, see if that would be a possibility. Rotation, notice you've got a short edge right here, the short edge, and the short edge on the other triangle is here. Well, if you were to rotate this shape at all, you couldn't get it in this formation, because if you rotated it, it's sort of like a mirror image of what that one looked like. So that one also wouldn't work, because as you can see, it must have somehow been flipped to change the order there. But if you're unsure, you can always draw a line of reflection to prove it. So let's draw our line. So to create the line of reflection, we have to do perpendicular bisectors. We have to find the perpendicular bisector between a point and its image. So we go on the point, and we have to change our compass width to more than halfway between the two. I'm picking these 2 points, by the way. And then we make a curve below it. And we make a curve above it. And then we go to the other point without changing the width and do the same thing. And then from there, we take our ruler and draw the line. And to show that it would be the same, you just look between two. You can draw, all right, this is from 0 to 1, so it's 1 full inch, but it's half an inch to the line of reflection. If you pick another point, so again, it's got to be halfway. So this one goes to 3 more slots above 1.5 inches. So just a note, this is a 1/2 inch, this is a 1/4 inch, the next smallest one is an 1/8, and the next is a 1/16. So this would be 8/16, 9, 10, 11/16. So 1 and 11/16 essentially, or you can just say 1 and 1.5 and then 3 more, 1.5 and 3 more. Okay, so it works. And that's how you make a line of reflection. All right, so now we have 2 more triangles, and I want you to figure out what kind of transformation it is and then create the part that needs to be created. So in this case, we have, if you see A, B, C, and then A prime, B prime, C prime. So from there, first, look to see if it would be a translation. Physically moving this one over to this one. However, notice that the orientation tilts a bit. Translations don't change orientation, so it's not that. Then you would look at a reflection. You might think, oh, there could be a line of reflection right here, so it would just reflect over. The issue with that, though, is look that here is B and here is A prime. So if that were to occur, this point would have to go onto this point, but B can't turn into A prime. A has to turn into A prime. So it's not a reflection either. So it's probably a rotation. And to prove it, we're going to make the center of rotation. So, again, this lesson's called Perpendicular Bisectors. So what we're going to do is create first the perpendicular bisector between A and A prime. So you made sure your compass is more than halfway between A and A prime, putting your point on A, and then you make a curve below and a curve above. And then without changing the width, same thing, curve above, curve below. And this one over here I'll have to make a bit wider because it didn't go quite far enough. Okay. So then I'd use my straight edge and draw a line. Okay. Then I have to make another perpendicular bisector. So let's this time go from B to B prime. You have to go from one point to its image. So more than halfway, make an arc below, an arc above. Same thing on the other side. Above, or below, above. And then this one I'll have to extend. And this one here intersected right there, so I don't have to extend that one. Okay? So then I make my intersection. And it's not going to intersect. We want these two lines to intersect, so I'm going to extend this all the way the length of the ruler. And then same for this one. I'm going to extend it all the way. And that's how you make the center of rotation. If I had a large enough protractor, I'd be able to find the angle of rotation by setting the center at this point and then connecting it with A and seeing where it goes to A prime. However, my protractor is not large enough, so I can't do that. But what I really wanted to stress was how to make the center of rotation. Alright, so here's the last thing I'm going to talk about. So another thing you can do with perpendicular bisectors is if you have 3 points, you can find out the point that's equidistant from all 3 points. If we're looking for a point that's the same distance from every one of these points, we can find that using perpendicular bisectors. So, take 2 points. The two easiest I see right here first are B and C, so let's go with that. And we want the perpendicular bisectors. So, it's going to be more than halfway. Go above and below. Above and below. I keep getting it, so it's like perfect intersection right there. Alright, and then we connect them. Then do the same with 2 more. Doesn't matter which 2. I'll just go A and B. So more than halfway. Above and below. Above and below, so they intersect. Okay. And so the point that's the same distance from each of the points is right here. Okay? A couple ways you can see that is by you can measure all 3. So A to the center, B to the center, C to the center. Another interesting way to do it is, so do you remember when we talked about points in a shape being equidistant from the center? So the only shape that does that for every point on the shape is a circle. So that means this right here is the center of a circle. And to see if it works, what we need to do is change the width to be the width from the center to one of the points, and we should be able to make a circle out of it using the compass. So let's try it. Okay, pretty decent. Went through each of the points. They're kind of big points, so it might be a little off, but so it went through each of the points and it made a circle. So that shows no matter what, any line that comes from the edge of the circle to the center will be equidistant. So that shows how that's made. So perpendicular bisectors can be used for so much, and that's why we do so much with them. They're also nicely one of the easiest constructions to make. Alright, that's it for the lesson today. Sorry, no sponge today. You don't all have compasses, so it'd be hard to do a sponge on this. Don't worry, we'll have a sponge when we get to the next video. Once again, please make sure to take notes on the entire lesson. You should have been taking notes on more of the directions on what I did. Some of the drawings may be helpful, but this is like the folding paper one where you're doing more of directions, except the vocab I did at the beginning of the video. Alright, now time for the sponge. We've got two problems here. Number one, the point is equidistant from three other points. Is also which center of the triangle. Equidistant, by the way, means equal distance, same distance. And number two, the point that is equidistant from three other points is also which part of a transformation. So it's a certain part of a transformation. What is that part? Alright, that's it for the video. Once again, please make sure to remember to take notes on the entire video, attempt the sponge, put your ranking from 0 through 3 at the beginning of your paper, take a picture of everything, submit it all to Google Classroom, and have a good night.